Have you ever wondered how your favorite apps actually work? Or, how Netflix just knows exactly what movie you want to watch next? Well, there's a really good chance a single, incredibly powerful language is pulling the strings behind the scenes. Today, we're going to dive deep into that language. Welcome to our explainer on Python. So, let's just kick things off with a quick question. What do you think powerful AI, the web apps you use every single day, and the complicated world of data science all have in common? What's that invisible thread connecting all these amazing technologies? Yep, you got it. It's Python. This one language has kind of quietly become the backbone of our digital world. It's working behind the scenes, making so much of this incredible stuff possible. So let's get into what really makes it so special. All right, so what is Python really? I think the subtitle here says it all, the language designed for humans. And that's not just marketing talk. See, unlike a lot of other programming languages that kind of force you to think like a computer, Python was built from day one to be intuitive for people. Here's the more official definition. Let's break that down real quick. General purpose just means you can build pretty much anything with it, from websites to robots, you name it. And high level, that part's absolutely key. It means the language is way closer to how we speak than it is to raw machine code. And this really captures that idea perfectly. A low-level language, that's like trying to speak the computer's native language, just a rigid stream of ones and zeros. But a high-level language like Python, it lets you express these really complex ideas in a way that feels a lot more natural. It's almost like you're just writing a sentence. So that brings us to the big question, right? Why? Why has Python become such a huge deal? Well, the answer really lies in this unique set of, let's call them superpowers, that make it just so incredibly effective. And here are those superpowers laid out. The syntax is simple and easy to read, which makes it way easier to learn. It's interpreted, meaning you can write a line of code and see the results immediately, no waiting around. It's dynamically typed, which is a fancy way of saying you have to write less boring setup code before you can get to the fun part. It also has a massive standard library. Seriously, think of it like a giant toolbox just packed with pre-built tools for anything you can imagine, all included for free. And finally, it's cross-platform. The exact same code you write will run on a Mac, on Windows, or on a Linux machine with no changes. It's amazing. Oh, and just a quick technical note for you. When we're talking about Python, we're really talking about Python 3. That's the modern, current, and fully supported version that pretty much everyone is using today. Okay, so we know what it is, and we know why it's so popular. But how does it, actually work? How do those English-like instructions you write get turned into something the computer's brain can understand and act on? Well, it's actually a pretty simple three-step process. First, you write your human-readable instructions. That's your source code. Next, the Python interpreter acts like a universal translator. It takes your code and converts it into this intermediate language called bytecode. Think of bytecode as a perfectly prepped set of instructions. And then finally, the Python virtual machine, or PVM, is like the manager on the factory floor. It reads those instructions and tells the computer's hardware exactly what to do. And the result of that whole process? It can be something as simple and elegant as this. This one line of code is genuinely one of the most famous programs in history. All it does is tell the computer one thing: show the words "Hello World" on the screen. That's it. It's clean, it's readable, and it just works. Now, like any language, Python does have some rules, but don't think of them as these super complex laws you have to memorize. It's much better to think of them as a simple, straightforward grammar that just helps keep everything organized and easy to read. So this table shows the basic grammar for naming things in Python. You can use letters, numbers, underscores, but you can't start a name with a number. Simple enough. But here's a really important one that trips up a lot of beginners. Names are case sensitive. That means my var with a capital V is a totally different thing from my var with a lowercase v. Just following these few simple rules keeps your code so much cleaner. And here's another great example of how human-friendly Python is. It lets you leave comments right in your code. Anything on a line that comes after a hash sign, that's a number sign or pound sign, is completely ignored by the computer. It's just a simple way to leave notes for yourself or for other people to explain why your code is doing what it's doing. Okay, so we've covered the what, the why, and the how. Now for what I think is the most exciting part. What can you actually do with this language? This is where we see the incredible power of Python out in the real world. I mean, the list of what you can build is just huge. Python is the engine behind massive web platforms. It is the undisputed king of data science and machine learning. You can use it to automate boring tasks on your computer, build powerful cybersecurity tools, develop games. You can even create desktop and mobile apps. And that's the real magic right there. Python scales from the absolutely massive to the tiny and personal. You can use it to analyze gigantic data sets at a huge tech company, or you could just use it to automatically rename 1,000 files on your own laptop. The power is just as useful in both of those worlds. So there you have it. We've gone from zero to understanding the heart of Python. It's a language that was designed to be readable, it's packed with these amazing superpowers, and it's capable of building pretty much anything you can dream up. This isn't just a tool for computers, it's a language for creation. So the only real question left is, what are you going to...
All right. Welcome, everyone. This is your first and honestly most crucial mission in the world of Python, mastering the setup. If you're ready to start building with one of the most powerful programming languages out there, well, you've come to the right place.
So you want to build something big with Python, right? Maybe you're dreaming of creating the next big web app, or training a powerful AI model, or maybe just automating the boring parts of your job. Whatever it is, it all starts with the code, and that code needs a rock-solid foundation. And I get it, I really do. Setup can feel like such a drag, but here's the thing. I want you to think about it differently. This isn't a chore. This is you building your personal launchpad. Getting this part right now, is going to save you so many headaches later on. Trust me on this.
Okay, here's our game plan, our mission briefing, if you will. We're going to start with the installation, then run our very first piece of code. After that, we'll unlock the power of Python's App Store with pip, create a clean workspace with venv, and wrap it all up with a final system check. Sound good? Let's dive in. First things first, we are installing the core engine. You know, you can't even think about hitting the racetrack until the engine is actually in the car. Same thing here. So, your first move is super simple. You're going to head over to python.org, that's the official home of Python, and grab the latest stable version of Python 3. This makes sure you have all the newest, most secure tools ready to go. Okay, now pay close attention to this one. This slide is so important. These little checkboxes can make or break your whole setup. The most important one, and I mean non-negotiable, is add Python to path. Seriously, do not skip this. Think of the path as a set of directions for your computer. By checking this box, you're telling your computer exactly where to find Python so you can run it from anywhere. And make sure pip is checked too. We'll see just how critical that is in a little bit. All right, so the installation finished. That little progress bar is full, but did it actually work? Let's not guess. Let's confirm it. It's time for our first real system check. Just pop open your terminal or command prompt and type in this one little command, python-version. If you see a version number pop up on the screen, boom! Congratulations! Mission Objective 1 complete. This little check proves your computer now speaks Python, and it sets the stage for everything we're about to do. So the engine's in. Now time to turn the key and hear that thing roar. Let's bring your very first piece of code to life. Now you've got two main ways to run Python code. There's interactive mode, which is kind of like texting with Python. You type the command, hit enter, and it responds right away. It's perfect for quick little tests. Then you have script mode. This is where you'll do your real building. You write all your instructions in a .py file, and then you tell Python to run the whole thing at once. So let's try script mode. Just create a new file, name it example.py. Inside, type print hello Python. Now save it, open your terminal, find where you saved the file, and run python example.py. When you see hello Python appear on your screen, that's it, that's the moment. You've officially written and run your first Python program. Welcome to the club. This is huge because you've just proved you can give your computer a command and it will listen. That's the heart of programming. Okay, so you can run basic code. Now it's time to unlock some superpowers. Let's talk about pip. Think of it as Python's very own personal app store.
Here's the magic of pip. You don't have to reinvent the wheel. The Python community has already built millions of incredible free tools. We call them packages, and you can install them with just a single command. Need to analyze data? There's a package for that. Want to build a website? Yep, there are packages for that too.
And look how simple it is. Seriously, these three commands are going to be your best friends. Pip install adds a new tool. Pip uninstall gets rid of it, and pip list shows you everything you've got.
Why is this a big deal? Because mastering pip is your ticket to standing on the shoulders of giants and building really complex applications really fast.
Okay, so you're installing all these cool packages and your projects are getting bigger. But wait, what happens when one project needs version 1 of a package but another project needs version 2? Things can get messy fast. That's why you need a personal workspace.
A virtual environment, or VNV for short, is basically an isolated bubble for your project. Think of it like giving each of your projects its own personal, clean, private toolbox. This way, the tools for one project don't get mixed up with the tools for another. This is a professional best practice that will save you from a world of chaos.
And setting one up is super easy. You create it with one command, then you activate it, which is like stepping inside that private workspace. You can see the command is just a little different for Windows versus Mac OS or Linux. When you're done working, you just type deactivate to step back out. Getting this workflow down, create, activate, deactivate, is a fundamental habit for keeping your projects clean and trouble-free. We have all the pieces. Python is installed, we can run code, we can manage packages, and we can create these isolated workspaces. It is time for one final check to confirm that our entire launch sequence is green. So here's a quick pro-level checklist for you. If you're using an editor like VS Code, get the official Python extension. It's a game changer. Make sure your editor knows which Python interpreter to use. That's super important when you're using virtual environments. Double-check that path variable we talked about. Remember, that lets you run Python from anywhere. And finally, get comfortable using the terminal that's built right into your editor. With all systems checked and our environment ready to go, there's only one thing left to do. Run one last diagnostic and get that amazing feeling of confirmation that our setup mission is a complete and total success.
Go on, run this in a script. Seeing setup complete pop up in your terminal, that's not just running code. That's your victory lap. It means your environment's configured, your tools are ready, and you are officially prepared to start building. And that brings us to the end of our mission. Your launchpad is built, it's tested, and it's ready for liftoff. You're standing at the starting line with one of the world's most powerful programming languages at your fingertips. The only question...
Welcome, everyone. Today, we're diving into what is, without a doubt, the most important first step you'll take on your coding journey, getting your Python environment set up. You know, getting this right from the get-go is going to save you so many headaches later on. I mean, you're here, so I'm going to guess the answer is a huge yes, right? Whether your goal is to build the next big website, crunch some serious data, or maybe even dabble in AI, it all starts right here with a solid foundation. And that's exactly how I want you to think about this. We're not just, installing some software. No. We are building your own personal digital workshop, and we're going to stock it with all the tools you need to create some truly incredible things. So let's get to it. First things first, in any workshop, you need the big stuff, right? The main workbench, the power tools. For us, that's the core Python installation itself. Okay, so you're going to want to head straight over to the official Python website. Make sure you grab the latest stable version of Python 3. You might see older versions or beta releases. Just ignore those for now. We want the tried and true, super reliable toolkit to get us started. Now, as you're clicking through the installation, you're going to see a few checkboxes. This slide is super important. The most critical one is Add Python to Path. Seriously, don't miss this one. Think of it like putting a giant sign in your workshop that says Power Tools are here. It just lets your computer find Python from anywhere, which is absolutely essential. All right, once that installer finishes up, let's double check that it all worked. Go ahead and open up your computer's command line. That's called Terminal on a Mac or Command Prompt on Windows, and just type in that simple command. If you see a version number pop up on your screen, success. Your main workbench is officially installed. Okay, this is where it gets really exciting. The power's connected, the tools are bolted down, it's time to flip that big red switch and see this workshop in action for the very first time. So, you've basically got two main ways to use your Python tools. First, there's interactive mode. This is kind of like grabbing a screwdriver for a single quick turn. You type one command, you get an immediate answer. It's perfect for quick tests. Then you've got script mode. This is for when you're actually building something. You write out all your instructions, your whole blueprint, in a file, and then you tell Python to run the whole thing at once. And, as you get more experience, you're going to want to upgrade your workshop. Tools like VS Code and PyCharm are what we call IDEs, Integrated Development Environments. Just think of them as these state-of-the-art, all-in-one workstations that make building big, complicated projects way, way easier. Okay, the main tools are in.
Now let's talk about organization, because a great builder isn't just skilled, they're tidy. We're going to add a proper toolbox and some project-specific bins to our workshop. Trust me, this is what separates the pros from the amateurs.
All right, let me introduce you to your new best friend, Pip. Pip is one of the most important tools you'll use. It's like having this huge online catalog where you can order any specialty tool or package, as we call them, that you could ever possibly need for any project. And using this catalog couldn't be easier. Pip List shows you all the tools you already have in your workshop. Pip Install lets you order a brand new one. And hey, if you don't need a tool anymore, Pip Uninstall sends it right back. So efficient. Next up, we have something called a virtual environment. The most important word to remember here is isolation. This amazing tool lets you create a completely separate, self-contained workspace for every single project you work on. And this is the perfect way to think about it. Imagine you're in a real workshop, building a wooden chair, and right next to it, you're building a metal sculpture. You wouldn't want your sawdust getting all over your welding gear, would you? Of course not. A virtual environment gives each project its own perfectly clean workbench with only the specific tools it needs. No mess, no mix-ups. It's brilliant. And setting one up is just a simple 3-step process. First, you build the new workbench. Second, you activate it, which is basically like saying, okay, I'm working at this bench now. And then when you're done for the day, you just deactivate it and step away. Now, that activation command is a little different depending on your computer. This slide breaks it down for you. Just find the one for your system, Windows, macOS, or Linux, and that's the command you'll use. All right, we did it. We installed the main tools, we set up our entire organization system, so I think it's time for the grand opening. Let's do one last check to make sure the lights are on and our workshop is officially ready for business. So for this final test, all I want you to do is create a brand new file. You can call it something like test.py. And inside that file, you're just going to write one single line of code. This is it. This is the whole thing. Print setup complete. It's a really simple command that just tells Python, hey, display this text on the screen for me. So save that file, run it from your terminal, and if you see those 2 magical words pop up, setup complete, then you did it. Your workshop is built, it's organized, and it is officially open for business. That is awesome. Congratulations. Which really only leaves us with one final exciting question. You have a brand new, fully equipped workshop sitting right in front of you, ready to tackle anything. The only limit now is your imagination. So, what are you going to create? Hey everyone, and welcome. If you've ever thought about learning to code, well, you are in exactly the right place. Today, we're taking that very first step into the world of Python, one of the most popular and, honestly, most powerful programming languages out there. Let's dive right in. But before we get into the nitty-gritty, I want you to think about this for just a second. What do you want to build? Seriously, is it a website? An app? Maybe you want to analyze a bunch of data for a project. Just hold that idea in your head, because what you're about to see is just how many doors Python can open for you. And there you have it. Whatever you were just picturing, there's a really good chance Python is the tool for the job. You can build entire web applications, dive headfirst into data science and machine learning, write little scripts to automate the boring stuff in your life, and yeah, you can even get into building games. It really is the Swiss Army knife of the coding world. Okay, so we know it's powerful, we know it's versatile, but what is it really? What is Python at its heart? Let's peel back that first layer and find out. So here's the textbook definition. It's a high-level, general-purpose language. Now, high-level is just a fancy way of saying it reads a lot like English, which makes it way easier for us humans to understand. And general-purpose? Well, that just means it's not a one-trick pony. You can use it for almost anything. But the 2 most important words on this slide, readability and simplicity. That's the secret sauce. And those core features are exactly why Python is so amazing for beginners. The syntax is clean, almost like you're writing out a set of simple instructions. It's also what we call an interpreted language, meaning the computer runs your code one line at a time, which makes finding mistakes so much easier. Then there's dynamically typed. All that means is you don't have to tell Python ahead of time what kind of data you're working with. It's smart enough to figure it out on its own. Now, that's incredible for getting started fast, but it can be a bit of a double-edged sword. On really big projects, that flexibility can sometimes lead to some tricky bugs down the road. Okay, one quick but really, really important thing before we go any further. You're going to hear people talk about Python 2 and Python 3.
Here's all you need to know. Python 2 is history. It's outdated, it's not supported anymore. All new projects, all learning, everything we're talking about today, it's all about Python 3. That's the one you want. Period. All right, enough with the theory. Theory's great, but it's time to actually get our hands dirty. Let's take a look at what real Python code looks like and get you to write your very first program. But as you're getting ready to type, have you ever wondered how that actually works? How do the words you write on a screen turn into something the machine can actually understand? It's not magic, I promise, but it is a pretty cool process. Think of it like a 3-step translation. First, you write your code, your instructions, in a file. That's your source code. Then, the Python interpreter steps in. It's like a translator, converting your human-readable code into an intermediate language called bytecode. Finally, the Python virtual machine, or PVM, takes that bytecode and tells the computer exactly what to do. It's a smooth little journey from your brain to the machine's actions. And here it is, the rite of passage for every single programmer on the planet, the Hello World program. It's just one simple command, print. You follow it with what you want to say, wrapped up in parentheses and quotes. That one little line is all it takes to make your computer talk. It's your first milestone, and it's a huge one. So now that you've seen a real line of code, let's talk about the basic rules of the road. Just like any language, Python has a kind of grammar we need to follow, so that the computer understands exactly what we mean. The first rule, funny enough, is about writing things that the computer completely ignores. These are called comments. Think of them like little sticky notes you leave for yourself or for anyone else reading your code. They explain the why behind what you're doing, and trust me, they are absolutely crucial for writing code that actually makes sense later on. And Python gives you 2 easy ways to do this. For a quick, short note, you just start the line with a hash symbol. That's it. But if you have a longer explanation, something that might take a few lines, you just wrap the whole thing in a set of triple quotes. Super simple. Okay, next up, we have a slightly technical-sounding word, identifiers. But don't let the name intimidate you. An identifier is just a name. That's it. It's what you decide to call the things you create in your code, like variables that hold data or functions that perform actions. And just like naming anything, there are a few simple rules. Your names can have letters, numbers, and underscores, but they can't start with a number. Now, this next one is super important. Python is case-sensitive. That means name with a lowercase n is a totally different thing from name with a capital N. And finally, there are a few special words that are off-limits. And these are them. They're called keywords. Think of these as words that Python has already reserved for special jobs. Words like if and else are for making decisions, and for and while are for doing things over and over again. You can't use these as your own names, because Python's already called dibs on them. And there you have it, the absolute foundation. You now know what Python is, why it's so popular, how your code actually runs, and the basic rules for writing it. You have all the pieces you need to write that first program. You've taken the biggest, most important step on this journey. So the only question left is the one on the screen. Your hello world is ready. What are you going to say to them?
Hey, if you're just getting your feet wet with Python, you are in exactly the right place. Today, we're going to break down the one concept that absolutely everything else is built on: variables and data types. Let's get right into it.
So first, let me ask you a question. Think about it for a sec. When you log into an app, how does it remember your username from one screen to the next? Or when you're playing a game, how on earth does it keep track of your score? See, a computer needs a way to hold on to information, and the answer to that puzzle is exactly what we're talking about today. And here's the answer: the variable. You know, the easiest way to picture a variable is to just think of it as a labeled box. Seriously, you give the box a name, you put something inside it, and that's pretty much it. It's just a named container for a piece of data that your program needs to remember. This super simple idea, it's the bedrock of all programming.
So, here's our game plan. We're going to follow the entire life story of a variable. First, we'll see how it's born, what a variable even is. Then we'll get to the fun part, the naming ceremony, and learn the right way to name it. After that, we'll peek inside and see all the different kinds of stuff we can put in the box. And finally, we'll see how to actually use that data to make our programs do cool things. All right, let's start at the very beginning, creating our first data container. This is the moment where we basically tell Python, hey, I need a spot to store something. Give me a box. Now, what makes Python so awesome, especially for beginners, is that it's dynamically typed. That's just a fancy way of saying Python is smart enough to figure out what's in the box for you.
You put text in, it knows it's text. You put a number in, it knows it's a number. You don't have to declare it beforehand, and you can even swap out what's in the box later on. Talk about flexible, right? Okay, so we've got our box, but what do we call it? Well, it turns out there are a few simple rules we gotta follow. Think of it as the official naming ceremony for our variables. Don't worry, the rules are pretty straightforward. First, a variable name can't start with a number. So price1 is totally fine, but oneAge is a no-go. You can use an underscore, like in user_name, but other special characters like a hyphen are out. And here's a big one. Names are case-sensitive. A lowercase age and an uppercase age are two completely different boxes to Python. Lastly, you can't use words that Python has already reserved for itself, like the word class. So, what if you have a value you never, ever want to change, like the value of pi? Well, Python doesn't technically have a way to lock the box, but the programming community has this kind of gentleman's agreement. It's a convention. If you write a variable name in all caps, you're signaling to other developers, hey, you really shouldn't change this. It's basically a hands-off sign that works on the honor system. We have our named box. Now for the really interesting part. What kinds of things can we actually put inside it? And this brings us to the whole concept of data types. Now, Python has a bunch of data types, but these 5 are the absolute essentials. You're going to use these every single day. We're talking whole numbers, numbers with decimals, plain old text, true or false values, and a special one for when there's, well, nothing there at all. Let's quickly break down each one. First up, we've got the integer, or int for short. This is any whole number, positive or negative, no decimal points allowed. You see these everywhere, the number of items in your shopping cart, your score in a game, you name it. Simple, right? Next, we have the float. If your number needs a decimal point, it's a float. This is what you'd use for a price, like $9.99, or for scientific measurements. The second you add that dot, boom, it's a float. A string, or str, is how Python deals with text. Anything at all that you wrap in single or double quotes becomes a string. A username, a password, a comment on a blog post. If it's text, it's a string, period. Now for a really powerful one, the Boolean, or bool. A Boolean can only ever be one of two things, true or false. That's it. This is the foundation of all decision-making in your code. Think of it like an on-off switch. Is dark mode on? True. Is the user logged in? False. It's that simple yes or no that makes everything happen. And finally, there's this unique one, none type. Its only value is none. You use this when you need a variable, a box, but you don't have a value for it yet. It's not 0, and it's not an empty piece of text. It's deliberately nothing. It's a placeholder, an empty box just waiting to be filled. So with all these different types, what happens if you forget what you put in the box? Well, Python gives you a handy little tool for that. The type function is like a little scanner. You can point it at any variable and it'll tell you exactly what data type is inside. Super useful for figuring out what's going on in your program. All right, we have created, named, and filled our variables. Let's get to the final section. How do we actually work with them to make our programs interactive and, useful? A super common thing you'll do is get information from a user. Python's input function is great for this, but there's a catch, and it's a big one. It always gives you back a string. Even if the user types in the number 10, Python sees it as the text 10. So, if you want to do math, you have to convert it. This is called typecasting. By wrapping the input with int, you're telling Python, hey, I know this looks like text, but I need you to treat it like a whole number. Python also has some really slick shortcuts to make your code cleaner. On the left, you can set up a bunch of different variables all in one go. And on the right, you can give a whole chain of variables the exact same value. They're just nifty tricks to write less code. And just as variables can be created, they can also be destroyed. When you're totally done with a variable and want to free up that little bit of computer memory, you can use the del keyword. And just like that, the box and its contents are gone for good. So, let's wrap this all up. At the end of the day, variables are just those named containers, those labeled boxes that hold all the info your program needs. Understanding how to create them, name them properly, and put the right kind of data inside them, that is the absolute first and most important step to becoming a Python programmer. We've covered the what, the why, and the how of Python's most essential building blocks. You now officially have the power to make a computer remember things. So the only real question left is, Now that you can store data, what will you build?
You know, when you look at a line of Python code, what do you really see? Sure, you see variables and functions, but what about all those little symbols tucked in between? The plus signs, the equal signs, all of that. They're not just punctuation. They are the operators, the action words that literally bring your code to life. They are the essential building blocks that turn your static list of instructions into a real working program.
So that really makes you wonder, right? How does a script actually do anything? How does it go from being just a list of commands on a screen to something that produces a useful, tangible result? Like, calculating a shopping cart total, or checking a password, or making a character jump in a game. Well, the answer is all about operators. The best way to think of them is as the action words, or the verbs of your code. They're the symbols that grab your data, your variables and your values, and actually perform operations on them. They add, they compare, they assign. Bottom line, they make things happen.
So here's our game plan for this explainer. We're going to kick things off with what operators actually are. Then we'll cover the absolute basics, math and assignment. From there, we'll see how code makes decisions, how to check our data, and finally, we'll get into the super important rules for the order of operations.
Okay, let's dive right in. First up, what exactly are Python operators? Honestly, the best way to think about them is as the tools in your programming toolkit. Each one has a very specific job to do. And these tools, they fall into a few key categories. You've got your arithmetic operators for doing all the math. Then there are assignment operators for storing values. You've got comparison and logical operators, which basically give our code a brain to make decisions. And we even have membership and identity operators for taking a closer look at our data. We're going to get into all of them.
All right, let's start with the absolute basics, math and assignment. If we're thinking about building a program, these operators are like the bricks and mortar. They are the most fundamental, most common actions your code is ever going to take.
So these should look pretty familiar from math class. You've got your standard addition and multiplication. The double asterisk, that's for exponents, but what's really interesting here is the difference between the two kinds of division. A single slash, that'll give you a precise decimal answer, so 2.5 in this case. But the double slash, that's floor division. It just chops off the decimal and gives you the whole number, which is 2. And then there's the percent sign, the modulus. It just gives you the remainder of a division, super useful for things like checking if a number is even or odd.
Now, the single equals sign is probably the operator you'll see more than any other. It just assigns a value to a variable. Simple. But Python also gives us these fantastic shortcuts. Instead of typing out x equals x plus 3, you can just write x plus equals 3. It does the exact same thing, adds 3 to whatever x is and updates it, all in one go. It's just cleaner, more efficient, and you'll see it everywhere in Python code.
Okay, so we've laid the foundation with math and assignment. Now it's time to build the walls. This is where our code stops just doing calculations and starts thinking. It starts making decisions using logic. At the very heart of all this decision-making are the comparison operators. They ask a simple question, like, is 5 equal to 5, or is 7 greater than 10? And here's the crucial part. The answer is always a simple true or false. This is called a Boolean, and it's basically the little switch that tells our program which path to take next. But what if you need to check more than one thing at a time? I mean, life is complicated, right? That's where logical operators come into play. And, or, and not let you chain multiple comparisons together to create some pretty complex rules. With and, every single condition has to be true. For an or statement, you just need one of them to be true. It's a lot more flexible. And this is a perfect example of how Python actually thinks. So let's pretend we have a variable, age, and we set it to 20. Python looks at this expression and evaluates it piece by piece. First up, is age greater than 18? Well, 20 is greater than 18, so that's true. Okay. Next, is age less than 30? Yep, 20 is less than 30, so that's true as well. Finally, it just has to evaluate true and true, which, of course, gives us a final answer of true. All right, next up, let's talk about inspecting the build. Sometimes you don't need to do a calculation or make a big decision. You just need to check your data to see what's inside a variable or how two things are related to each other in memory. The in operator is your go-to tool for this. It's super simple. It just lets you check if a certain value exists inside a sequence, like a string of text or a list of items. For instance, is the letter A inside the word cat? Yep, it is. So this whole expression just becomes true. It's a really clean, readable way to check for membership. Now, the is operator is different, and this is a really important distinction to get. It doesn't just check if two variables have the same value. It checks if they are the exact same object living in the same spot in your computer's memory. Think of it this way. You and I could have two separate copies of the same book. The content is equal, but they aren't the same physical book. The is operator checks if X and Y are just two different names for that one single book. It's all about identity, not just equality. And for our last section, we need to talk about the rules. For our code to be stable and predictable and not just do random things, it needs a blueprint, a set of rules that dictates the order in which things happen. This is called the order of operations, or operator precedence. So, have a look at this. 10 plus 2 times 3. If you just read it from left to right, you might think, okay, 10 plus 2 is 12, and 12 times 3 is 36. But is that what Python does? This is a classic trap for beginners, and the answer all comes down to precedence.
Just like in math class, when you learned PEMDAS, Python has a strict hierarchy. It doesn't just read left to right. At the very top of the list, you've got exponents. Then comes all the multiplication and division stuff. After that, it'll handle any addition and subtraction. And way, way down at the bottom are your comparisons and logical operators.
So, let's solve our little puzzle. When Python looks at 10 plus 2 times 3, it sees a plus sign and a multiplication sign. It checks its rulebook and sees that multiplication has higher precedence. So it evaluates 2 times 3 first, which gives it 6. Now the expression is just 10 plus 6, and the final result, 16. That's the blueprint in action.
And this is why it matters so much. Getting precedence wrong doesn't usually cause your program to crash. It's a logic error. Your code will run just fine, but it will silently give you the wrong answer. And believe me, those are the most infuriating bugs to track down. Understanding these rules is what makes your code reliable.
So there you have it, arithmetic, assignment, logic, and all the rules that hold them together. You now have the fundamental building blocks of programming, the real tools that make code come alive. So the only question left is, what?
Ever wonder how a game knows you've just leveled up? Or how your favorite app decides which notification to pop up on your screen? Well, it's not magic. It all comes down to a program's ability to make decisions. And today, we're going to pull back the curtain on how Python's if statements give your code that exact power, the power of choice.
So, how does a simple script go from, just blindly following a list of commands to actually thinking? It's a great question, right? Just like us, for a program to be truly useful, it has to look at a situation and decide what to do next. It has to be able to ask that one fundamental question, what if?
And the way we make that happen? It's with something called conditional statements. This is the absolute core concept that lets our code react, adapt, and really come alive. It's what turns a dumb script into a smart, responsive application. I want you to think of conditional statements like forks in the road for your code. Imagine your program is on a journey. It reaches a decision point, and it has to check a condition, kind of like reading a signpost. And depending on whether that signpost says true or false, it gets sent down a completely different path. It's all about controlling that journey, telling the code where to go next.
Now, Python gives us this awesome toolkit for building these decision points. First, we've got the basic check, the if statement. Then, we'll look at handling two paths with if-else. And finally, we'll tackle those really complex choices with if-elif-else. So, let's gear up and get started.
All right, first up is the absolute foundation of all decision-making in code. It's the simple but super powerful if statement. This is our starting point for asking a single, straightforward question. The logic here is so simple. You use it every day. We just ask a question, are you over 18? If the answer is yes, then you can vote. If the answer is no, well, for now, we just move on. The basic if statement is perfectly designed to handle just that yes scenario. And the beautiful thing is, the syntax in Python is just as clean and simple. You've got the keyword if, then you pop in your condition, and you finish it with a colon. Now that colon, that little guy is so important. It's basically telling Python, hey, the next part is what you do if this condition is true. Okay, let's see this in action. We set a variable, age, to 18. Then our if statement kicks in and checks, is age greater than or equal to 18? Well, yeah, it is. So that condition is true, and the indented code right below it runs, printing eligible. It's that simple. And this basic check, it's the engine behind everything from a website login to making sure you filled out a form correctly.
So, that basic if is great, but what about when the answer is no? What if we want to do something specific in that case? We don't want to just, ignore it and move on. We need an alternate path. And that is exactly where if-else comes into the picture.
This is the perfect example of a binary choice. There are only two possible outcomes, right? If you get more than 33 marks, you pass. If you get anything else, you fail. It's one or the other. There is no middle ground.
Okay, so take a look here. On the left, you've got our simple if from before. But on the right, we've upgraded it. We've added the else block. Now, the really important thing to get here is that else is like a catch-all. If that first if condition isn't met, the code under else is guaranteed to run. It's the otherwise path. Let's walk through this. Our marks are set to 40. The code asks, are marks greater than or equal to 33? Yep, 40 is, so it prints pass, and then it completely ignores the else block. Its job is done. But let's say the marks were 30. Now, that if condition is false, so it skips the pass part and jumps straight to the else block, printing fail. See how that works?
Okay, so we've handled one path and we've handled two. But what happens when life and our code gets more complicated? What if there are 3, 4, or even more possibilities? Think about a game deciding if you get a bronze, a silver, or a gold medal. For that, we need to bring out the big guns, our most flexible tool, the if, elif, else chain. The way this works is like a waterfall or a cascade. Python starts at the very top with the if. It checks it. If it's false, it flows down to the next level, the first elif, which, by the way, is just short for else if. It keeps going down the chain, checking each elif one by one until it finds a condition that's true. As soon as it finds one, it runs that code, and then, this is key, it jumps out of the entire block. The else at the very bottom is just our final safety net for anything that didn't match along the way. Now with this setup, the order is absolutely critical. Let's trace it with a score of 85. Python starts at the top. Is the score 90 or above? Nope, 85 isn't, so it moves on. Next question, is the score 75 or above? Yes, it is, so it prints B, and it stops right there. It doesn't even bother to look at the else statement. Mission accomplished. Okay, awesome. We've got the 3 main structures down cold. Now before we wrap up, let's look at a few power-ups you can use. And one absolutely crucial rule that will make your code way more powerful and save you from a ton of headaches later on.
All right, let's do a quick lightning round of pro tips. You can use and or to combine checks for more complex conditions. Python also lets you do these cool chain comparisons to see if a number is in a certain range. You can even nest if statements inside other if statements for really deep logic. And hey, if you ever need an empty block for some reason, the pass statement has got your back. But the most important rule of all, the one rule you absolutely cannot forget in Python is indentation. Seriously, those spaces at the beginning of the line aren't just for looks. They are how Python knows which code belongs to which if, elif, or else.
So, let's put it all together in one final real-world example. Imagine the temperature is 30. Our code first checks the if. Is the temperature over 35? Nope. It moves down to the elif. Is it over 20? Yes, it is. Boom. It prints normal, and its job is done. Just like that, we've built a simple, smart little program that can actually assess the temperature and give us a useful, human-readable report.
So there you have it. We've just equipped you with the fundamental toolkit for making your code intelligent. You now know how to handle a single option, a simple choice between 2 paths, or even a whole complex chain of possibilities. So the only real question left is, what's the—
Hey there, and welcome! Today we're going to dive into one of the most powerful and, honestly, fundamental tools in any programmer's toolkit, Python loops. This is where your code really starts to do the heavy lifting for you.
I mean, we've all been there, right? Copying and pasting, typing the same thing over and over, it's just, so tedious. But what if you could just tell your computer to handle all that repetitive work for you flawlessly every single time? Well, guess what? You totally can. That is exactly what loops are for. They're this super elegant solution to that whole problem of repetition, and they let us automate tasks and make our code just incredibly efficient. Now, in Python, we've basically got 2 main workhorses for this job, the for loop and the while loop. And yeah, they both repeat code, but they go about it in slightly different ways. And we're going to break down both of them. All right, so let's kick things off with the for loop. The way I like to think about this one is as your predictable, step-by-step tool.
It's absolutely perfect for when you know exactly how many times you want to repeat something. So the core idea here is actually really simple. A for loop just takes some kind of sequence, like a list of things or even a string of characters, and it walks through them one by one. And for every single item it hits, it runs a block of code. Pretty straightforward, right?
Okay, so a super common tool you'll see with for loops is the range function. Let's look at this example. When you see range 5, what Python does is it creates a sequence of numbers starting from 0 all the way up to, but not including, 5. So you get 0, 1, 2, 3, and 4. The for loop then just grabs each of those numbers one at a time and does whatever you told it to do inside the loop. This table is actually a fantastic way to see just how flexible range is. See, you can give it just one number, a stop value, like in that first row, or you can get more specific and give it both a start and a stop value, like in the second example. And even cooler, you can add a step value, like we did in that third row, to count by 2s or 3s or, whatever you need.
And hey, don't think for loops are just for numbers. Not at all. A string is really just a sequence of characters, right? So you can loop through it just as easily. This code right here is just going to walk through the word Python. So on the first pass, it grabs the P, then the Y, then T, and so on, doing something with each character along the way. Super versatile.
All right, time to switch gears and talk about our second type of loop, the while loop. Now, if the for loop was all about doing something a set number of times, the while loop, well, it's all about doing something as long as a certain condition stays true. For this loop, the condition is king.
I mean, the logic is literally right there in the name. It's going to run that block of code while the condition you set is true. The very second that condition becomes false, bam, the loop stops.
So let's actually trace this code and see how it works. First, we set up a counter. We start it at 1. Then the loop kicks in. It checks. Is count less than or equal to 5? Yep, it is. So it prints the count. Then, and this part is absolutely crucial, we increment the count, adding 1 to it. This whole cycle of checking, printing, and adding repeats over and over until count hits 6. Then the condition is false and the loop is done.
So here's the big takeaway, right? It's all about picking the right tool for the job. You're going to reach for a for loop when you know you're working through a list or you know exactly how many times you need to run. But you'll use a while loop when you need to keep going until something changes. Like maybe you're waiting for a user to type something or waiting for a sensor to give you a certain reading.
But, and this is a huge but, there is a major warning that comes with while loops. If you forget to include a way for that condition to eventually become false, like if we forgot to add 1 to the counter in that last example, that loop will run forever. Seriously, it's called an infinite loop, and it's a classic programming mistake. So pro tip, always give your while loop a clear exit strategy.
Okay, so you've got the basics down. Awesome. Now it's time to level up. Let's look at how you can get even more precise control over your loops, which makes them even more powerful.
First up is the break statement. The best way to think of this is like an emergency stop button. It doesn't just skip one little part, it completely kicks you out of the entire loop, right then and there. So in this example, even though the loop was supposed to go all the way to 9, the second I equals 5, break hits, and it's game over for that loop.
Now, continue is a little different. It's not a stop button, it's more like a skip button. When your code hits continue, it just abandons whatever's left in the current iteration and jumps straight to the top of the next one. So here, when I is 2, the continue gets triggered, and any code that came after it for that round gets totally ignored. The loop just moves right on to 3.
Okay, now for something that's a really cool, kind of unique Python feature, you can actually put an else block on a loop. Think of it like a completion bonus. This block of code will only run if the loop finishes its entire run normally. If you use a break statement to cut the loop short, that else block gets skipped completely. Pretty neat, huh?
All right, theory is great and all, but let's see this stuff in action. Now that we know how to control our loops with this kind of precision, let's put it all together and check out the real power of these tools with a couple of practical examples.
So let's say we have this list of numbers. Yeah, for this little list, we could add them up in our heads, sure. But what if there were 1,000 numbers, or 1,000,000? That is a perfect job for a loop.
And here's exactly how we do it with code. We start by creating a variable called total and setting it to 0. Then our for loop just grabs each number in our list, one by one, and adds it to that running total. It's so simple, so clean, and just incredibly effective.
And boom,
Just like that, the loop crunches through the list and gives us our answer, 10. Now just imagine doing that with a list of thousands of items. It would take a fraction of a second. That's the kind of power we're talking about here.
But hey, loops aren't just for number crunching. They can be used for creative stuff too. This bit of code uses a loop to print out a cool pattern. It runs 5 times, and each time through, it prints a number of stars that's equal to the current loop number. It's a really simple idea that gives a really cool visual result.
And there it is. The result is this really nice, simple triangle pattern. The first time through the loop, we get 1 star. The second time, 2. The third, 3. And you get the picture. It's just a perfect visual of how a loop can build something up step by step.
So there you have it. We've seen how loops work, when to use a for versus a while, and how to control them with things like break and continue. These things are basically the engine of automation in your code. So the only question left is,
All right, let's get into it. Have you ever felt like you're just typing the same lines of code over and over again when you could be building real, powerful tools? Well, that's exactly what we're talking about today. We are going to fill up your coder's toolkit with one of the most essential, most powerful items in all of programming, the Python function. So let's open up that toolbox and get started. So take a look at this. On the left, in that before box, that's the nightmare of repetitive code, right? It's a tangled mess. The same logic is just copied and pasted all over the place. It's a headache to read. And if you need to change one little thing, you gotta hunt it down everywhere. Now, look at the after box. See that? Clean, simple, direct. That is the magic of a function. It packages all that chaos into one single elegant command. So the big question is, how do we get from that messy before to that beautiful after? We start by crafting the blueprint. And in this first section, we're going to build a basic Python function completely from scratch. This is the most fundamental tool in our entire kit. At its heart, a function is really just like a specialized tool. You know, like a wrench designed for one very specific bolt. It's a reusable block of code that does one particular job. You build that tool once, give it a name, and then you can grab it and use it whenever you need that exact job done, over and over and over again. And you know what? Building one is actually super simple. It's really just these 4 steps. First, you use the def keyword. That's basically you telling Python, hey, I'm defining a new tool here. Then you give it a good descriptive name and add those parentheses. Inside of that, you write the actual code it's going to run. And finally, this is where the magic happens. You call it by its name to make it all happen. That's it. But what if you want your tool to work with different materials? That's where parameters come in. Think of those parentheses as a kind of doorway. The parameters, like the A and B you see here, are just placeholders for the data you pass through that doorway. This is what makes your function dynamic and seriously powerful. And if parameters are the way in, then the return keyword is the way out. After your function does its job, return is how it actually hands a result back to your main program. It's like it does the calculation and says, here's that answer you asked for. This is how functions give you something useful back. Okay, so we've built our basic tool. It takes stuff in and it gives stuff out. But a truly great toolkit has tools that can adapt to anything. So now we're going to look at how to upgrade our functions to handle pretty much any job you can throw at them. A fantastic feature you can add is a fallback plan. By setting name equals guest, we're giving our function a default value. So if you call the function without providing a name, no problem, it just thoughtfully uses guest. But if you do provide a name, like yesWant, it uses that instead. This makes our functions way more robust and a lot easier to use. And here is another upgrade that makes your code so much clearer. Keyword arguments. Instead of having to remember the exact order of your inputs, you can just label them, just like you see here. Age equals 20, name equals Rahul. Now there is zero confusion about which value is which. It's awesome. Your code practically documents itself. This is a fantastic question. I mean, we've planned for 1 or 2 arguments, but what if you need a function that can add up 2 numbers, or 10, or maybe 100? How in the world do you build a tool that flexible? Well, the answer lies in these 2 incredibly powerful little things, args and double K args. Check it out. Args is like a bag that collects all your extra inputs, the ones that depend on their order, and bundles them all up. On the other hand, double K args does the same thing, but for the named inputs, collecting them into a dictionary. This is the secret to ultimate flexibility. Okay, we've covered the essentials. Now,
let's take a quick peek behind the curtain. We're going to do a rapid-fire look at a couple of advanced techniques. You know, the kind of secrets that really unlock the full power of functions and separate the beginners from the pros. First up is this idea of scope. Think of it like this. A variable you create inside a function has local scope. It's like it lives and dies inside that function's house. But a variable defined outside everything has global scope. It's out on the street where everyone can see it and use it. And trust me, understanding this difference is absolutely crucial for preventing some really weird bugs in your code. Next, meet the Lambda function. I love these. I call them the pocket multi-tool of Python. It's a tiny, anonymous function that you can write on a single line. It doesn't even need a name. It is absolutely perfect for those moments when you just need a quick, simple operation done right now without all the ceremony of a full def statement. And this slide just shows the difference perfectly. On one side, you've got a standard function to square a number. It works just fine, but it takes 2 lines. On the other side, the Lambda function does the exact same thing in one short, clean, elegant line. For simple tasks, that kind of efficiency is just beautiful. Okay, we have covered a lot of ground. We've built our basic tools, we've looked at some advanced attachments, so now let's bring it all together and talk about the best practices that separate a good coder from a great one. Let's talk about mastering your craft. So why do we care so much about functions? Well, because they basically give you coding superpowers. They let you reuse code so you don't have to repeat yourself, which naturally creates a clean, organized structure. And because your code is broken into these logical, modular chunks, finding and fixing bugs becomes infinitely easier. And here's the mark of a true professional: documentation. This little piece of text you see here, called a docstring, is basically the user manual for your function. It explains what your tool does. And writing clear docstrings means that other people, and more importantly your future self, will thank you for making the code so easy to understand at a glance. So there you have it. We've explored the entire blueprint, from simple definitions all the way to flexible arguments and professional best practices. You now have the fundamental knowledge to start building your very own custom tools. So the only question left is, what amazing tool are you going to build? Hey everyone, welcome. Today we're diving deep into something you use constantly in your code: text. We're going to master Python's strings and turn them from just simple characters into a super powerful tool for wrangling data. Let's jump right in. I mean, just think about it for a second. Text is everywhere in your code, right? User input, file paths, stuff you get from an API. It's all just text. So how does Python actually make sense of it all? How does it handle this fundamental building block of pretty much every program you'll ever write? Well, that's exactly what we're going to unpack today. All right, let's start at the beginning. We've got to build a solid foundation. So what even is a string in Python? Okay, so here's the official definition. A string is an ordered and immutable sequence of characters. Ordered is pretty simple. It just means every character has its own specific spot in line. But immutable, that's the keyword you really need to remember. It means once you create a string, you can't change it, ever. When you think you're modifying a string, what's actually happening behind the scenes is Python is creating a brand new one. And this isn't just some abstract idea. It has real-world consequences. Let's say you have the string hello, and you try to swap out that first H for a Y. Nope, Python is going to shut that down immediately with a type error. It's basically telling you, hey, you can't change me. This really hammers home that core rule. You don't modify strings, you make new ones. So if we can't change strings, what can we do? Well, our real power comes from being able to pull out the exact pieces we need. Let's check out the blueprint for accessing parts of a string. Okay, so think of a string like a row of houses on a street. Each character is a house and it has a unique address, which we call an index. Now, what's cool is that Python gives you 2 different ways to find any house. You can start from the left at house number 0. Yep, we always start counting at 0 in programming. Or you can start from the end of the street, with the last house being number -1. So in our Python string, P is at index 0, but it's also at index -6. Kind of neat, right? This whole idea is called slicing. The basic syntax is start/end. But here's the one thing you've got to remember. It grabs everything from the start position up to, but not including, the end position. That trips people up all the time. If you leave the start empty, it just assumes you mean the very beginning. And if you leave the end empty, it goes all the way to the end. And this last one?
/0/1. That is a super clever, almost magical trick to just instantly reverse an entire string. How cool is that?
So let's see this in a real example. We've got the string Python programming. If we want just the word Python, we can slice from index 0 up to 6. If we want programming, we can just say start at index 7 and go to the end. And look at that reverse trick in action. //1, and bam, the whole thing is flipped backwards. It's just so powerful and clean.
Okay, so we've got the basics down. We know what strings are, how to pull pieces out of them. Now it's time for the fun stuff, the power tools. These are the built-in methods that let us do some serious text manipulation. First up, the simple stuff, changing the case. You've got .upper, which, basically makes your string shout, and then you have .lower, which does the opposite. This is super important for making text consistent, especially when you're dealing with, say, user input, where you don't know if they're going to use capital letters or not. All right, let's talk about cleaning up messy text. The .strip method is a lifesaver. It gets rid of any accidental spaces, what we call white space, from the beginning and the end of a string. Super handy. Then you have .title, which is perfect for making things look nice and tidy by capitalizing the first letter of every single word. Great for names or headlines. Now, .replace is basically your find and replace tool. It hunts down every time one piece of text appears and swaps it out with something else. So here, we're just telling it to find world and replace it with Python. And remember, because strings are immutable, this gives us a totally new string. Okay, this one is a huge deal. .split is a real game changer. It takes one long string and chops it up into a list of smaller strings. All you have to do is tell it what character to use as the chopping point. Here, it's a comma. This is incredibly useful for parsing data, like from a comma-separated values file, a CSV. And of course, if you can split things apart, you need a way to put them back together. That's where .join comes in. It's the exact opposite of split. It takes a whole list of strings and glues them together into one single string. You can use whatever character you want for the glue. So split and join are like two sides of the same coin. Perfect for taking data apart, working with it, and then reassembling it. All right, here's a quick lightning round of a few more useful methods for searching. .find will tell you the exact index number where a smaller string starts, super useful. And then you have .starts with and .ends with. These are just simple checks that return true or false. Are you dealing with a PDF file? Just check if the file name .ends with .pdf. Easy. Okay, we've spent a lot of time tearing strings apart and changing them, but what about building new ones from scratch? Especially when we need to mix in data from variables. Let's talk about construction and formatting. The easiest way is actually use operators you already know from math. You can just use the plus sign to stick strings together. We call that concatenation. And you can even use the multiplication sign to repeat a string over and over. It's simple, it's intuitive, and it just works. But for anything more complex, you're going to want to use proper string formatting. Now, there are a few ways to do this. You might see some old code using this %style formatting, or maybe the .format method. And look, they work, but the modern and by far the best way is using f-strings. You just pop an F right before the opening quote, and then you can drop your variables directly into the string inside curly braces. It is so much cleaner and easier to read. Seriously, just use f-strings. So we've got this whole toolbox now, right? Slicing, methods, formatting. That's all great. But what's the point? How does this all come together to solve actual problems you'll face as a developer? Let's check out the real-world payoff. And this is where all clicks into place. Got some messy user input with weird spacing and random caps? No problem. You just chain .strip and .lower together to sanitize it. Need to pull the domain name out of an email address? Easy. Just .split it at the @ symbol. Want to make sure a URL is secure? Just check if it .starts with HTTPS. See? Each one of these little tools solves a specific, common problem, and when you start combining them, they become incredibly powerful. So there you have it. We've gone from seeing strings as just simple text to understanding them as this amazing, flexible toolkit for slicing, dicing, cleaning, and building data. You now have the core skills you need to handle pretty much any text-based task in Python. So the real
All right, let's dive into one of the most fundamental, most important data structures in all of Python, the list. Seriously, whether you're building a game, crunching numbers for a business, or just organizing your thoughts, mastering lists is absolutely essential. So let's see how they work.
So here's what we're going to cover. First, the basics. What even is a list? Then we'll get into how you actually access and change the data inside. After that, we'll look at organizing and searching, and we'll wrap up with some seriously cool power moves that'll make your code way better.
Okay, first things first. What exactly is a Python list? Well, you can think of it as the basic blueprint for holding a bunch of different things together in one neat and tidy package.
I mean, think about it. Let's say you need to keep track of the top 5 scores in a game. Are you going to create 5 different variables? What about 100? No way, that would be a total nightmare to manage. There's got to be a better way, right? And that's exactly the problem lists were made to solve.
And here it is, the solution. A list. Now, there are 2 words here that are super important. First is ordered. That just means your items stay in the exact order you put them in. The second is mutable, which is just a fancy way of saying it's changeable. You can add things, remove things, and swap things out whenever you want.
You know, a really good way to picture a list is like a numbered shelf. Each spot has a number, and you can stick whatever you want on it. And get this, unlike in some other programming languages, a single Python list can hold all sorts of different data types together. Numbers, text, true or false, anything goes. It's incredibly flexible.
Okay, so we've put our stuff on the shelf. Now how do we get it back? Let's open up the toolkit and see how to access our data.
So the most direct way to grab an item is by using its index, or its spot on the shelf. Just remember, Python always starts counting from 0, so the very first item is at index 0. But here's a super cool trick. You can also count backwards from the end using negative numbers. Items -1 will always give you the very last item, which is so useful when you don't even know how long the list is.
But what if you need more than one item? A whole range of them? Well, instead of grabbing them one by one, you can take a slice. You just give it a start and an end position, and boom, you get a whole new sublist. Now, the one thing you got to remember is that the slice goes up to, but doesn't actually include, the end index. So items 1 to 4 gives you the items at index 1, 2, and 3.
All right, let's talk about that key property we mentioned earlier, mutability. Remember how we said lists are changeable? This is where that really comes into play. We have a whole bunch of tools to add, remove, and update our items whenever we want.
So the easiest change you can make is just updating a value that's already there. You just point to the item using its index and use the good old equal sign to assign a new value. Just like that, you're swapping out what's in that spot for something totally new.
Now, when it comes to adding new stuff, you've got 3 main options. If you just want to tack something onto the very end, .append is your go-to method. Simple. If you need to be more precise, .insert lets you pick the exact spot to put your new item. And if you have a whole other list you want to add, .extend will merge all of its items onto the end of your original list.
Removing items is just as flexible. The first question to ask yourself is, do you know the value of what you want to remove, or its position? If you know the value, like the word apple, you use .remove. If you know the index, you can use .pop or the del keyword. A really cool thing about .pop is that it actually hands you back the item it removed so you can still use it. And if you just want to burn it all down, .clear will empty the entire list for you.
Okay, let's be real. Your list can get big and, well, kind of messy. That's where organizing and searching come in. These are the tools you're going to use to bring some order to that chaos and find exactly what you're looking for.
When you need to sort something, Python gives you 2 choices, and you really need to know the difference. The .sort method sorts your list in place, which means it permanently changes your original list. The sorted function, on the other hand, leaves your original list alone and gives you back a brand new sorted copy. Which one you use totally depends on whether you need to keep that original order around.
Here are a few other handy tools for your toolbox. You can reverse a list, again, in place. You can use index to find out where an item is located, or you can count how many times a specific value shows up. But honestly, one of the most common things you'll do is just check if something is even in the list. And for that, the super clean and readable in keyword is perfect.
We have covered the fundamentals. Now, let's get to the really fun stuff, the elegant Pythonic ways of working with lists. This is where you really start to level up your programming game.
Okay, so let's say we want a new list with the first 5 square numbers. The traditional way to do this is to create an empty list, loop through some numbers, calculate the square, and then append it. It's 3 lines of code. It works, it's clear, but it's not the slickest way to do it.
And this
is the Pythonic way, a list comprehension. It does the exact same thing as those previous 3 lines, but all in one elegant, readable, and usually faster line of code. You can literally read it like a sentence. Give me a list with x times x for every x in the range of 5. It's an absolute game changer.
But wait, it gets even better. You can build logic right into the comprehension. Look at this. We're not just creating a new list, we're also filtering it at the same time. This one line basically says, give me a list of n for each n in our numbers, but only if n is an even number. It's such a powerful way to transform and filter data all in one go.
One last crucial power move, copying. Now, be careful here. If you just use an equal sign, you're not actually making a copy. Both variables will point to the very same list in memory. Using .copy makes a shallow copy. It's a new list, but if you have lists inside your list, both copies will share those inner ones. To make a totally independent clone of everything, you need a deep copy. It's a subtle point, but it can save you from some really confusing bugs down the road.
So why does all of this matter so much? Because lists are literally everywhere in Python. They're used to store anything you can think of: student grades, items in a to-do list, data points on a graph. They are the backbone of how we filter data, manage tasks. In fact, they're the foundation for what other languages call dynamic arrays.
So to wrap this all up, what do you need to remember? First, lists are ordered, and most importantly, they are mutable. They're changeable. Second, getting really good at indexing and slicing is your key to getting at your data. Third, learn to love list comprehensions. They'll make your code cleaner and more efficient. And finally, just know that the Python list is one of the most powerful and versatile tools you'll ever use.
So we've given you the blueprint, the toolkit, and the power moves. You now have a really solid foundation for handling all.
All right, today we are diving into one of Python's most essential building blocks. It's a data structure that's super simple, incredibly secure, and honestly a little bit overlooked: the tuple. So, let me ask you this. Have you ever had a collection of data where the absolute last thing you wanted was for it to change by accident? I think we've all been there. Well, if that feeling is familiar, then you're about to meet your new best friend in Python.
And here it is, the tuple. Now, at its core, it's just an ordered collection of things, kind of like a list. But it has one single critical feature that changes everything. It is immutable. And that's the big word for today. All it means is unchangeable. Once you make a tuple, its contents are locked in. Period.
I absolutely love this analogy because it just makes it click. Think of a Python list as a whiteboard. You can write on it, you can erase things, you can add new stuff. It's super flexible. A tuple, though, that's like taking the same information and carving it directly into stone. It's permanent, it's secure, and it is not going anywhere.
Okay, so theory is great, but how do we actually make and work with these carved-in-stone data structures? Let's get our hands dirty. You're going to see it's actually really simple.
So you've got a few ways to whip one up. The most common way is just using parentheses. But, Python's pretty smart. It can usually figure out you want a tuple even without them. Now, listen up, because here is the one thing that trips people up. If you have a tuple with just one element, you have to put that comma at the end. Without it, Python just thinks it's a number. And of course, you can always just convert a list over. Super easy.
And here's some good news. Getting stuff out of a tuple works exactly like it does with a list. You just use square brackets with the index you want. So T0 gets you the very first element, and T-1 is a handy little trick to grab the very last one. Simple.
And yeah, just like with lists, you can slice out a piece of a tuple. This doesn't change the original at all. It just hands you a brand new, smaller tuple with the elements you asked for. It's a really efficient way to just grab a piece of your original data.
All right, so we've tossed around this word immutable a bunch, but what does that really mean when the rubber meets the road, or, when the code actually runs? Let's see this unchangeable rule in action, because this is the single most important thing to get about tuples.
And this right here shows it all. On the left, we take a list and change its first element. No problem, works like a charm. But then we try the exact same thing to a tuple on the right, and bam, Python slams on the brakes and throws a type error. This isn't just a gentle warning. Python is enforcing that carved-in-stone rule. It's telling you the object itself just doesn't support that kind of change.
So what do you do if you're in a spot where you absolutely must modify the data that started out in a tuple? Well, there's a simple little 3-step dance you can do. You convert it to a list, make your changes on that flexible whiteboard, and then you just convert it right back into a brand new, secure tuple.
Okay, now for one of the most elegant and, I gotta say, Pythonic features about tuples, packing, and unpacking. This is where tuples start to feel less like a data structure and more like a superpower.
This is called tuple packing, and it's so natural you might have done it without even knowing it. When you just assign a bunch of comma-separated values to one variable, Python is quietly creating a tuple for you behind the scenes. It's just so clean and tidy. And unpacking is just the reverse. You have a tuple, and you want to assign each of its elements to its own variable. As long as you have the same number of variables on the left as you have elements in the tuple, Python just deals them out perfectly. It is incredibly useful. And this is where it gets really powerful. By adding a little star or an asterisk, you can do what's called extended unpacking. Here, A gets the first value, and that star B tells Python, hey, just scoop up everything else and toss it into a new list for me. This is an absolute game changer.
So, we've seen what they are, we've seen how to use them, but the real question is, why? Why would we ever choose a data structure that's so restrictive on purpose? Let's get to the payoff. Here you go, the 4 big superpowers, and they all come from that one core idea, immutability. Because Python knows a tuple can't change, it can make them run faster and use less memory than lists. You get that built-in data security, no accidental changes. And this third one, this is a biggie. Their unchangeable nature means you can use them as keys in a dictionary, something a list can never do.
This is a classic example you'll see everywhere. A function needs to give you back more than one value. Instead of some clunky workaround, you just return the values separated by a comma. Python automatically packs them into a nice, neat tuple for you. It's clean, it's simple, it's efficient. Right, this is a huge advantage. Dictionary keys have to be what's called hashable. They need to be constant so the dictionary can find them quickly. Since lists can change, they can't be keys. But tuples, being immutable, are perfect for the job. This lets you do really cool stuff, like using a coordinate pair to look up a city name.
And finally, maybe the most intuitive use of all. Anytime you have data that represents a fixed thing, a tuple is your go-to choice. Think about it. A point on a graph has an x and a y coordinate. A row of data from a database has an ID, a name, and age. A tuple signals to everyone reading your code that this is a single unit of data that isn't meant to be changed. So it's pretty clear that tuples are way more than just read-only lists. They are a specialized tool for when you need your data to be fast, safe, and totally reliable. So the next time you're dealing with coordinates or database records or returning multiple values, just ask yourself, do I need a flexible whiteboard or do I need a permanent, secure stone?
You know, in Python, there's this incredibly powerful data structure that, for some reason, just gets overlooked all the time. But it can clean up your data in a single step and totally supercharge your code's performance. So today, we're going to unlock the power of your new secret weapon, the set. All right, let me ask you something. You've got this long, messy list, right? And it's just filled with duplicate entries. How do you get just the unique items and do it in one clean, elegant step? Come on, if you've ever written any code, you've definitely run into this exact problem. And then, bam, with a single line of code, it's done. That messy list becomes perfectly clean. No weird loops, no complicated logic. I mean, it really does feel like magic. So, what is the secret tool behind this incredible trick? Well, the secret, of course, is the set. So let's really dig in and break down what a set actually is and why it's so perfect for a job like this. Okay, so here's the official kind of textbook definition. A set is a collection, just like a list, but it plays by a few very special rules. And trust me, it's those rules that give the set all of its power. Let's look at the 4 core properties that make a set, well, a set. First, and this is the big one, no duplicates. This is the magic we just saw. A set will simply not allow the same item to exist twice. Second, they're mutable, which just means you can add or remove things after you create it. Third, the elements inside the set have to be immutable. So you can throw in numbers and strings, but you can't put in something that can change, like a list. And finally, sets are unordered, meaning the items are just kind of floating in there with no reliable sequence. All right, enough theory. Let's get our hands dirty and see how to actually create and change sets in your own code. Okay, listen up, because this is a classic beginner's mistake, a real insider tip. If you want to create an empty set, you have to use the set function. If you just use those empty curly braces, Python will think you're trying to make an empty dictionary. It's a tiny detail, I know, but it can save you so much time debugging later on. Adding elements to a set is super simple.
If you just want to add one single item, you use the .add method. But if you want to add a whole bunch of items at once, like everything from a list, you use .update. Easy enough. Now, for taking elements out, you've got two choices, and the difference between them is really, really important. If you use .remove and the item you're trying to remove isn't actually in the set, your whole program will crash with an error. But if you use .discard and the item isn't there, nothing happens. It just shrugs and moves on. So you have to ask yourself, do you need to know if the item was missing, or do you just want to make sure it's gone? Okay, now this is where things get really cool. We're about to see how sets go from being just a simple collection to being this high-speed tool for data analysis. These are what I like to call the 4-set superpowers. First up is the union. Think of it like merging two-party guest lists. You take everyone from the first set, everyone from the second set, you put them all together, and it automatically gets rid of any duplicates. What you're left with is one big set with every single unique person from both of the original lists. Next up, intersection. This is all about finding the overlap. It answers the question, what do these two sets have in common? It's like finding which friends you and I both know. You get back a brand new set that only has the elements that exist in both of the originals. Then we have difference, and this works pretty much just like subtraction. It gives you all the items that are in the first set minus any of those that also happen to be in the second set. But, and this is really important, order matters. What you get from S1 minus S2 is completely different than what you get from S2 minus S1. And our final superpower is called the symmetric difference. Now this one gives you all the elements that are in one set or the other, but not in both. It's basically the perfect opposite of an intersection. It's everything that is totally unique to each set. So you know how every superhero seems to have a twin or a counterpart? Well, for the Chet set, its twin is the Frozen set. It's definitely less common, but it solves a very specific and very important problem. Look, the difference here is incredibly simple, but it's profound. A regular set is mutable. You can add and remove items all day long. A frozen set, on the other hand, is immutable. Once you create it, it's locked in. It's frozen. You cannot change it. That's the whole deal. So why on earth would you want a set that you can't change? Well, here is the killer reason. Python dictionaries absolutely require their keys to be immutable. You can't use a regular, changeable set as a dictionary key. It just won't work. But you can use a frozen set, and that one simple fact unlocks some really powerful and advanced programming patterns. We've covered the what and the how, but now let's talk about the most important part, the why. Where are you actually going to see sets being used out there in real-world code? This is where it all comes together. Need to get a unique list of user emails? That's a one-liner with a set. Checking if a user exists in a list of a million IDs? A set is almost instantaneous. I mean, it is orders of magnitude faster than a list because of how it stores data. Or what about managing user permissions? Finding out which roles two different users share is just a simple intersection operation. If you take away only one single thing from this explainer, please let it be this. From now on, whenever you hear the words unique or fast lookup, your brain should immediately scream set. That is their entire purpose, and that is their greatest strength. So I'm going to leave you with this challenge. Go look at your own code. Where are you keeping a list that really ought to be unique? Or where are you constantly checking if an item is in a huge list? I bet you there's a good chance you can just swap in a set and get an instant performance boost. All right, today we're going to talk about one of the most powerful and honestly essential tools in any Python programmer's toolkit, the dictionary. If you ever need to handle data in a smart, efficient way, well, mastering dictionaries is where it all begins. So here's our game plan. We're going to start with the absolute basics, what a dictionary even is. Then we'll get our hands dirty creating, accessing, and changing them. After that, we'll dive into some of the cooler, more advanced tricks. And finally, we'll tie it all together with real-world examples so you can see why this matters so much. Let's get into it. So what exactly is a dictionary? You know, the best way I've found to think about it is like a digital filing cabinet. It's a place where you store information, right? But instead of just throwing stuff in there randomly, every single piece of information gets its own unique label. Okay, let's get a little technical for a second. A dictionary is an unordered, mutable collection that stores data in key value pairs. Let's break that down, because those words are important. Unordered just means the items don't have a specific numbered sequence. Mutable means you can change it, add things, remove things after you've created it. And the most crucial part,
key-value pairs. Every piece of data, which we call a value, is tied to a unique identifier, its key. And here's a perfect example of what that looks like. We've got a dictionary here called student. The key is the string name, and its value is Yeshwant. The key age points to the value 22, and the key city points to Lucknow. See how that works? It's just a super intuitive way to keep related info bundled together. All right, so we get the what. Let's move on to the how. It's time to actually build our first digital filing cabinet and then, learn how to open the drawers and find the stuff we stored inside. You've actually got a few ways to create a dictionary. The most common way, the one you'll see all the time, is just using curly braces, like in that first example. You can also use the dict constructor, which is handy sometimes. And of course, you can always just start with an empty one, a blank slate, ready for you to fill up. Okay, so how do you get data out of the dictionary? Now, there are two main ways to do this, and the difference between them is absolutely critical. The first way is using square brackets. You ask for the age key, you get the value back, no problem. But, and this is a big but, if you ask for a key that doesn't exist, your whole program can crash. Ouch. The safer and often better way is the .get method. It does the same thing if the key is there, but if it's not, it just calmly returns none. No drama, no crash. The big takeaway here is if you're not 100% sure a key exists, use .get. It'll save you a lot of headaches. The cool thing about dictionaries is that they're not set in stone. They're living, breathing data structures. You can add new info, update what's already in there, and get rid of stuff you don't need anymore. Let's see how that works. Adding a new entry is almost laughably simple. You just refer to a key that doesn't exist yet, like email here, and assign it a value. And just like that, our student dictionary now has an email. It's that easy. And you know what's great? Updating an existing item uses the exact same syntax. If the key, like age, is already in there, Python just overwrites the old value with the new one. So here, our student just had a birthday and is now 23. Simple as that. So what if you need to get rid of some data? For that, the .pop method is your best friend. You just tell it which key you want to remove, and it neatly plucks out that entire key value pair, leaving the rest of your dictionary perfectly intact. Okay, basics are down. You ready to level up? Because this is where we go from just using dictionaries to really understanding their elegance and their true power. This is the advanced magic. A lot of the time, you're going to need to loop through everything inside your dictionary. And you've got options. You can loop over just the keys, which is what happens by default. You can grab just the values by using the .values method. Or, and this is probably the most useful one, you can get both the key and the value at the same time by using .items. And here's a quick look at some of those power tools we were just talking about. We've seen keys, values, and items. Update is fantastic. It lets you merge two dictionaries together. And clear? Well, clear is the nuclear option. It wipes out everything, leaving you with a totally empty dictionary. Now for one of my absolute favorite features in all of Python, dictionary comprehension. This is just a super clean, super readable way to build a dictionary in a single line. Look at this code. We're basically saying, for every number x from 0 up to 4, create a new entry where the key is x and the value is x squared. And boom, that one elegant line of code gives you this complete dictionary. This is exactly what people mean when they talk about Pythonic code. It's clean, it's efficient, and it says exactly what you mean to do. Okay, let's pause for a really important rule. This is a non-negotiable one you have to remember. Dictionary keys must be immutable. That just means they can't be changed once they're created. That's why things like strings, numbers, and even tuples work as keys. Their value is fixed. But you can't use something like a list because lists are mutable. You can add and remove things from them, and that would totally break how the dictionary works internally. So remember, keys can't change. So we've learned all the theory, we've seen the cool techniques, but the big question is always, so what? Why does any of this actually matter? Let's connect all this to the real world and see where dictionaries are the unsung heroes of programming. No, seriously, this isn't just some academic thing. Where do you actually use this powerful tool day to day? Well, the answer might surprise you. It's pretty much everywhere. Think about it. Whenever you're on a website, data is being sent back and forth. A huge chunk of that data is in a format called JSON, which maps almost perfectly to Python dictionaries. They're used all over the place. To store a user's profile, to manage the settings for an app, to represent a row of data from a database.
The list just goes on and on. That key value structure is just a natural fit for how we organize so much of our digital information.
And here it is. This is the secret weapon, speed. The real reason dictionaries are so fundamental is that looking up a value by its key is incredibly fast. On average, it takes the exact same amount of time whether your dictionary has 10 items or 10 times a million items. That's called O of 1, or constant time complexity. Think of it like this. Searching for a word in a book by flipping every page is like searching a list, but using the index at the back to jump straight to the right page, that's a dictionary. And that efficiency is a total game changer.
So there you have it. We've gone from the very basics to some of the advanced magic behind Python's most versatile data structure. You now have the key to organizing information in a way that's both powerful and incredibly efficient. The only question left is, what doors are you going to unlock with it? Thanks for joining me for